So in part 2 of this video series, we're going to add joinery to this arts and crafts table. For instance, we are going to add basically dado slots for these rails to drop in. And I'll go ahead and hide these rails so you can see that. Then our arched piece, I'll go ahead and hide that so that you can see that that is also notched. You can see the through mortises for our through tenons and our arch pieces. Even up top here, all of the apron pieces are also tongue and groove, mortise and tenon into the legs. So, and we will also be adding all the chamfer details that really make it look like an arts and crafts piece on the breadboard ends and on the ends of these arched stretchers and on the rails inside our table. So that's a brief outline of what we're going to do. So we are starting with this basic arts and crafts cocktail table that was created in the first part of the video, and we will go ahead and add joinery to it. So our first step is going to be the dados in our arch pieces right here. So first off, I'm going to add a new parameter, which we're going to need, which is our arch dado. That will be the depth of our dado cut in those arches. And actually I've already got this in the file, so that's going to be a 1/2 inch. Okay, so next we will proceed to rewind the timeline so that we don't have to do this in both pieces, in both arches. So if I go up to my top level component, that's the entire timeline, and I'm going to start rewinding here back to some mirrored commands to try to find where that leg was mirrored. I'm sorry, where the arch was mirrored. So there we see that there's an extrude for the arch, and if I move the timeline just to the right, we can see the other arch is made there. So I want to be before the mirror, but after the extrude that created this piece. So I'm now in the right place in the overall timeline, and I will go ahead and activate the arch component. And you can see that's a very simple timeline. And now we can go ahead and edit the sketch, which defined that arch. And I'm going to add a rectangle that we're going to extrude into this arch to cut that dado. So I am in the sketch. I will hit R for rect. And I'm just going to draw a rectangle up here, and then we'll use some constraints to position it where we want it. So the width of this rectangle is going to be the depth of our rails. So I'll type in rail and pick rail depth from the list, and then tab. Oops, things are moving around on me a little bit. I'm going to go ahead and finalize that rectangle just so it doesn't stop hopping back and forth. So now I want to get my dimension tool, so I press D for that. I come off this side, and this is going to be the depth of our dado. So that was the parameter we just defined, so arch dado. I'll press enter, and so the shape of the rectangle is defined, but I want to put it right on this top right here. So I already have a point here, which is a center point, because we used this center construction line for the arch when we defined that earlier. So this is pretty simple. All I need to do is come up to the midpoint constraint. I'm going to pick on this point right here and this line, and the whole rectangle gets automatically moved down to the center of the arch sketch. So I'm going to hit escape, and I'm just going to clean up these dimensions so that the next time we come back into the sketch, it'll make a little bit more sense. Okay, so we've defined that. And now we can exit the sketch. And now Fusion turned off our sketch, so let's turn it back on again. And let's go into the extrude tool. So I'll press E. I'll hover over this profile. and click. So that's our selected profile. Now we're going to do a cut instead of a new body. And for the distance, in this case, I'm going to pick all, which basically should cut all the way through this. So I kind of had to tell it the right direction. Let's see if I can do an all now. So distance all, there it is. So there's distance all in a cut operation. So I'll click OK, and the dado is cut. So now I have two other rails here, so I want to replicate that dado without having to put it in the sketch and without having to do more extrudes. So I will use the rectangular pattern feature, and it's already set to pattern features. So I'm going to go down to my timeline and select the extrude that just happened. And as I hover over that, you can see that this will get a darker color. So I know I'm on the right feature. So that's the object that I've selected. I now want to set the direction. So I'm just going to click on any line that's going in that direction. And I think I'm going to do spacing here. The quantity instead is defaulting to 3, but I want the number of rails that we have defined in our parameter list. That is currently 3, but we'll be able to change that parameter. The distance now is going to be our rail depth, the thickness of these rail pieces, times 2. Okay. Now that looks good, but they're both going in a left direction from center. So in this direction type, I can pick symmetric, and then I've got a feature on each side of the initial feature. Now this, I've found that sometimes this feature doesn't work unless you set this to optimized. I honestly don't understand the difference, but I often use that optimized. And so the feature worked. We got 2 more there. And now, now I think we're going to proceed on finishing this, so adding the through tenons to this arch piece before we allow it to be mirrored to the other side. Before we create the tenons on the ends of these arches, we're going to define a few more parameters. So I'm going to press Shift P to get into my parameter list. And I'm going to define 3 parameters. I'm going to click on plus here to do so. The first is going to be our arch tenon depth. And that's going to be, so the thickness of our tenon, that's going to be 7/8 of an inch. Why is it not like that? There we go, 7/8. Okay, I'm pressing plus again, and I'm typing in arch tenon height. Oops, my caps lock was on there, sorry. Arch tenon height, and that's going to be 2 3/4 inch. I'll put in 2.75, hit OK, and our final new parameter is going to be the arch tenon length. So that's the length of our tenon. And that's going to be 2 1/4 initially. Okay. So we'll get out of our parameter list, and we're going to our arch is already activated, so we don't need to do that. And now we're going to create a new tenon, but I think I'm going to pre-select this surface. I want to be sure that I get on that surface. And so I'm going to do my drill down technique. I'm holding down my left mouse button. I get this little pop-up. I can release the button and then cycle through these faces here, and when I see the correct one highlighted, I'll just click there. And now I'm getting blue confirmation that I've selected the right face. So now when I create a sketch, it's already pre-selected the plane to do the sketch on. So we're all set there. So now I'm going to, I think I'm going to draw this tenon out here in space and then use constraints to center it inside of the piece. So I hit R for rect. Actually, you know what? I'm going to use a center rect here because I think that'll save us a step. So I'm going to go to center rect, and this is creating a rectangle with a center already in it. And let's see. So the width here is going to be the arch tenon depth, which we just defined. And then I'll press tab and I'll put in the arch tenon height. Okay, and press enter. There's our rectangle. Now let's double click on that and just kind of hover it over here to make sure it looks right. It actually looks a little bit too, let me zoom out here. Actually 7/8 looks like that number should probably get adjusted. It's a little bit too much there. The height of this looks good. So let's go back into our parameter list and set this to say 3/4 of an inch. So Shift P, what was it? Arch tenon depth. I'm going to change that to 3/4. Okay. So that will automatically update this rectangle in the sketch. Let's move it over there, and that looks a lot better. Tell you what, we're going to go to the front view, so we're looking straight at it, and that's still a little strong in my mind. Let me go back there and do that again. Maybe even go down to 1/2 inch there. Okay, so back to the parameter list. Tenon, arch tenon depth. Oh, tenon, yeah, arch tenon depth, here it is. So let's see what a 1/2 inch looks like there. Okay. I think that's what we want. Oh yeah, that's much better. Okay. All right, so we want to position this rectangle in the center of this piece. So we don't really have a center here, but what we can do is get our line tool, go into construction geometry, and do 2 diagonal lines. And this is very much like what happens automatically when you do a center rectangle. It defines these 2 lines specifically so that you have a center point. You see there's a point there too. So one more thing to do is to go into our Create menu and pick Point. And at the intersection of those 2 lines, we can click and get our point. So now it's just a matter of making these 2 points coincident. And we will click on this one first, click to keep. So I'll go up to my coincident constraint, click here, and now our rectangle, a little hard to see, but our rectangle is centered within the piece. So our tenon is centered within the piece as well. Okay, so we will finish the sketch. And now it's just a matter of extruding this out. So if again, keep in mind we've got a leg in front of here. So I'm going to have to hold down my mouse button to drill through that leg. And there's a profile, and I can see it highlighted in blue. If this menu ever gets in your way, you can move this. So that's a face, body, leg. I don't see the profile anymore. So, oh, you know what? I changed the tab here. There's the profile. So I click, and now extrude. And now we want this to actually be a join. We want the tenon to be part of this body. Okay? So the only thing we really need to set here is join and the distance that we're going. And that's going to be our arch tenon length. So I will start with arch and go to tenon length here, and that looks good. Now you'll see that the arch tenon length, it's a through tenon. It goes right through the piece. So that's exactly what we want. So now that the tenon is created, we obviously need to make one on the other side, but I'm going to do the chamfer here first so that we can reproduce the chamfer along with the tenon when we mirror this over to the other side. Okay, so first off, I am going to get my chamfer tool, and you can pick individual edges, you know, hover over them and they would show up in this and set the angle of the chamfer and everything. But there's a much easier way to do it in this case. I'm going to go down here to select, and I'm going to click on this face. And now it's going to chamfer around the entire face automatically. So I'm going to put in 30 degrees for the chamfer, And then, oh, by the way, if you're not set to distance and angle here, you do want to select that. So distance and angle, 30 degrees for our angle, and our distance is going to be half the thickness of our tenon. So if we do arch tenon depth here, divided by 2, that should work. And we see in the preview that we get exactly what we want here. All 4 sides have been beveled. So I'm going to click OK, and now this tenon and its embellishment on the end are ready to be reproduced on the other side. So we will use mirror, and we are now going to mirror features, and features get selected down here in the timeline. So look at this in objects. It's plural, so we can select multiple objects. So I'm going to select the extrusion and the chamfer feature. And then we need to select a mirror plane. Here is our origin, so I'm going to pick that plane. If we maneuver around here, we can see the preview, and we can see our tenon is there and our chamfer is there. So I'm going to click on OK and wait a second, and there we go. So we are finished with the mirroring. So the final thing to do on this arch piece before it gets mirrored to the other side is to create 30-degree chamfers on basically these 4 faces that I'm hovering over. Okay, so we're going to use our chamfer tool, and I pop that up. I'm going to make sure I'm set to distance and angle, and let's see, I'm just going to start picking edges here. Now what I'm going to do is I'm going to go down one side first and click on the 4 edges that I would like beveled. And then the distance inward of the bevel is going to be our arch depth. I'll pick that out of the list, divided by 2. Okay, and let's see what we get. Oh, I've got 45 degrees. I'm going to set that to 30 degrees. And then let's just examine that to make sure that bevel looks proper and goes halfway through our piece, which it does. Okay, now I'm going to come around to the other side, and I'm going to pick 4 more edges. So I'll hit plus here. You see it looks like we lost the bevel, but it's still there. It'll still show up when we calculate this. So I'm picking 4 edges, and I'm going to put the same distance in, which is our arch depth divided by 2, and then I'm going to change the angle to 30, and let's see what we get here. Now we get something very different. It looks like it's the inverted angle, so I'm going to hit this flip button, and that fixes it. That's exactly what I want. We've got 2 equal bevels that meet in the middle. So I'm going to do an OK, and our bevel is done. So now that our arch piece is complete, we can navigate to the end of the timeline to watch it be mirrored to the other side and to get all of our other components in the drawing. But when we do so, we can see that there's 2 errors in the timeline. They're yellow highlighted. So let's look at the first one. And anything that has, these are actually warnings. An error would appear in red. But let's look at these 2 warnings. So I'm going to right click and go to review warning, and it says sketch plane is lost, cache is used, please redefine sketch to another plane. Okay, so what does that mean? I'm going to right click and edit the sketch just to get a little bit more information here, and we can see this is the sketch for our rail, and we can see that it was defined on the top of our arch piece, but that top no longer exists. We went back in time and we cut these dados, and then we did our beveling on the top. And basically we took away the 3D model that this sketch was referenced from. Now the nice thing is if we get this sketch to reference from the base of our dado, our rail will actually drop down too. So we not only solve this problem, but we begin to reposition the rail a little bit closer to where it's eventually going to be. So I'm going to get out of the sketch, and now I'm going to redefine this sketch plane. So I do that by right-clicking on the sketch that I want to redefine, and go up to redefine sketch plane, and all I have to do is select another plane or another face. So I'm going to select this face and click and OK. And now you can see a couple things happened. One, our error, our warning went away. And two, our rail pieces dropped down into the dado. Okay, so there's another warning here. So I'm going to right click on that and review that warning. This one says the model is using cast geometry to solve. Please reselect reference geometry for failed features in the timeline. So something wrong in our feature. So I'm going to right click on the feature. It's a rectangular pattern feature. I'm going to edit that. And then look in this dialog box. And here's our problem here. It says missing direction. So this is the direction of the rectangular pattern. I think what happened here is that we were picking the top edge of this arch piece, and the bevel took away the top edge. But we don't need specifically the top edge. We can reference any of these edges. But first we've got to click on missing direction, so Fusion knows that we're selecting something. And now I can pick any of these horizontal lines. I'm going to pick this one. And if we do an OK, and we look down in our timeline, the warning has gone away. So we've fixed our issues. And now what we want to do is we want to chamfer both ends, well, all ends of these rails. Now, we could go ahead and do it here, 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 and on the other three sides. But again, with some timeline manipulation, we don't have to do that. So we want to go back in time where there is a single rail. So timeline manipulation, you always want to go up to your top level. And I'm going to rewind our timeline. And you can see that that's the rectangular pattern for the grid array. And now all of our rails have gone away. So I want to come back to the right a little bit. And there's an extrusion and there's a single rail. So that's where we want to be. Right after that is going to be the rectangular pattern to create three of those. So if we back it up, we can chamfer both of these ends and then allow the timeline to go back to its end, and we'll get all of that for free. So right here, I want to use my chamfer tool. Now, you might think, well, don't you want to go select your rail and make that the active component? I think that's a good idea, but in this case, it's not actually necessary because Fusion knows that we're working on this particular component to do chamfering in it. So, good habit to be in, but not technically necessary here. So, I'm going to go to chamfer, and in this case, I want to chamfer all four sides. So that's great. I can just pick this face, and let's see if we can do two faces at once. Let's go around and pick this opposite face here too. And again, I don't have to do a shift click in these dialog boxes. I can just click. Okay, so we've got our two faces selected, and now it's a matter of setting our angle. Well, first we want to make sure we're in distance and angle. So we want to set our angle to 30 degrees. All these chamfers in this design are 30 degrees. And then we want half of our rail thickness. So I'm just going to type in rail, pick depth, divide it by 2, and our preview is showing us what we want on this end and showing us what we want on this end. So one chamfer command, we did both ends. So I'll click OK. And now we can go back to our top timeline, our top level timeline. And let's just move out one piece at a time. There we've reproduced our 3 rails with a rectangular pattern. And since we got our chamfer in before the other 2 rails were created, we get that for free. So next we want to cut our chamfers, our dados in these rails so that they will drop down farther on the arches. We're in the same kind of situation here. We want to back up the main timeline before this rectangular pattern. We can be before or after the chamfer, so I'm going to just go right after the chamfer. And now we can work on our rails. So we're actually going to manipulate a sketch now and then do an extrusion. So we do at this point want to select our rail as our active component. And I'll just collapse this arch to clean up our timeline a little bit. Okay, so let's open up the rail component, and we can see actually we don't have any sketches in here. So we're going to create a sketch inside the rail component, and that sketch is going to be on one of these faces. And now we want to, actually I think we want to hide this outside leg. So let's see if we can, of course I picked the wrong side. Let's see, our left front leg. Okay, so we've hidden the leg, and we want to do a sketch here so that we can basically do a notch here, and then we'll eventually move the rail down in the notch. But we want it positioned right where this piece is. So let's first off make our rectangle and then get it in the proper position. So I'm going to make our rectangle away from where we want it to be, and the dimensions I want, actually, since this is the dado, I'm going to back up a second here. I'm going to hit escape and go to our parameters and put a parameter in that defines the depth of that dado. So that is going to be rail dado depth, and I'm going to set that to 1 inch. Okay, and it's going to be the full thickness of the piece that it's going to notch over. So I go back to my rectangle tool, and now I've got my 2 dimensions. This one is going to be the arch depth. Okay, oops, I didn't pick it. I had it there in the list, arch depth. Okay, tab. And this is going to be our dado depth for our rail dado. So rail dado depth, and I'll press enter. Okay, so if I double click on this rectangle, I just want to temporarily move it over here, and I want to position it right there. So the question is how to do that. So I'm going to experiment a little bit and see if I can find a midpoint here. And if I can, I could just do a midpoint constraint from here to here. Let's see if I go in with a line tool and I kind of hover around here. I'm getting the midpoint of the arched piece, which is great. Now, is that still going to be there when I try to do a midpoint constraint? Let me click on midpoint, and I'm not getting anything, so I'm going to hold down my shift key. Still not getting anything. Okay, so then I'm going to go back to my line, make it a construction line, and I'm getting that midpoint here. So I'm just going to come up with a plumb construction line. I'll finish that. And now I believe we can get a point there. There's a point. So let's try to move to that midpoint and see what happens here. So I'm going to go midpoint of this little segment right here and the midpoint of this rectangle, and there it is. That moved. So the midpoint constraint worked there. So I will finish my sketch, and then I'll be able to do my extrude. So E for extrude. Looks like I got to go in a negative direction. I want cut as the operation, and I'm going to move it backwards, and then I'm just going to pick, instead of distance, I'm just going to say all. Now, in that case, it went through everything in the model there. So if I drop down this list and say, no, that's not what I want just the rail, I can turn off the arch and turn off the leg, and let's see what happens here. Okay, so that gave me the cut that I want. All right, so the next thing to do is to do that on the other side as well. Since we didn't go back in the timeline to the point where we could mirror that over during the initial extrusion of this, but we could go back into our sketch now that we've got that dado defined on one side. Simply edit our sketch, zoom in here, and I'm going to double click on any part of that rectangle. And now we can use mirroring inside of our sketch. So I'm going to click on the mirror. I've got my 4 objects pre-selected. I'm going to select my mirror line, and I don't see my origin planes, so I'm going to physically turn those on. And now I can hover over the plane that I want to mirror about. And there is my sketch, my dado rectangle mirrored to the other side. Okay. Now, instead of doing another extrude here, we have an extrude operation that's done. Let's turn our sketches back on. They've somehow turned off automatically. Okay, so there's our sketch back on. We extruded one side. So instead of doing a second extrude and having it in the timeline, complicating our timeline, why not go back to the original extrude and simply say, instead of one profile here, let's pick a second one. So that's the second profile. And I'm not liking what it's doing, showing it going all the way through here. So I'm going to turn all off. I'm going to change that to distance. And then our distance is going to be the thickness of our rail, or negative thickness of our rail. So I'm going to say rail depth. And that cuts all the way through. So wait for Fusion to do its thing. And now turn our sketch off. And we can see that we've got our dado nicely cut, and we are in, we're ready basically to drop this down onto the arched piece. So there's a couple of different ways to move this piece down so that it sits in the opposing dado. One of my favorite tools is the align tool. It really makes something like this pretty easy. And I just noticed that it's not in my timeline, in my toolbar, so I'm actually going to put it there. I'm going to go down to Modify, Align, and it looks like I've assigned it to a shortcut key because I use it so often. But I'm also going to hit these 3 buttons and then pin to my toolbar and probably move it to the left of my parameters. It kind of goes along with move. Okay, so if I do an align here, basically if I pick the 2 faces that I want to align, well, first off, I've got a dialog box, so I want to set that to components, and my from is a face in the component, so I'm going to hover over this face, which is the top of that dado, and then in my to selection in the dialog box, I'm going to zoom in and get this face right here. So now it drops that down so it's perfectly aligned, and I'm going to click OK. And now you'll see something popped up on the toolbar. We have this capture position or revert. If I hit a revert, it would go back to where it was. So we essentially did a move, but we did it through the align command. And I'm going to capture as well. Okay, so now it's in its position. So now when we go up to the top level component, activate that, and then come down to our timeline, right here is our rectangular pattern, and since the first rail, the central rail, was in its proper space, or its proper position, the other 2 got positioned properly during the rectangular pattern. And let's just go out to the end of the timeline and make sure our blocks are still in the right spot. And since they were derived from the rail, they are in the correct spot as well. So next I'm going to create the tenons on this stretcher. Now I want to save myself work, and I don't want to do it on both of these. I want to do it before the opposite stretcher gets mirrored. So again, we'll do our timeline manipulation. We'll go back in the timeline before this piece got created using a mirror. So we want to be in the top level component to do our timeline manipulation, and we want to go back to, basically I can just kind of scan to mirror commands and just go a little bit before them. And here's another one. I'll go before that. The next mirror is right here. That is the mirror of our longer pieces, the aprons. Here's one more mirror right here. That looks promising. So if we go forward here, you can see that is the exact mirror command. So we have to be before that. So I will just go one step before the mirror, and then we're going to define our tenon and go from there. Looks like I've got one of the legs hidden here, so I'm going to unhide that in the browser. All right, so we're in the right spot, but we're going to be changing the sketch of this stretcher. So I actually want to activate the stretcher if I'm doing any sketch manipulation or creating a new sketch. So let's see how the sketch is defined. I don't remember if it's sketching this profile and extruding backwards, or sketching the end profile and extruding in the other direction. So we'll edit the sketch to find out. And this is good news. It's the end profile. So we want to make a tenon inside here. And I think what I'm going to do is just make the tenon half of the overall width of the stretcher and half of the overall height of the stretcher. And then I want to center it exactly in the middle of the stretcher. So I'm going to use my center rectangle because that gives me a center point on the tenon. And then I'll have to create a second center point. So I'm just going to start the rectangle first. I'm sorry, a second center point on the piece itself. So I started the rectangle, and I'm going to hit D for dimension. I'm going to pull off here. Now I could type in our stretcher depth divided by 2, but I can also click on here and go over and grab this parameter. I know it's a parameter because it says FX, and click there, and then divide that by 2. So that is the same thing. That's actually it's the apron depth divided by 2. And this one's going to be our apron height. So I'm still in my dimension mode. So I pull a dimension off of here, click, come over to this dimension, and then type in /2. Okay, so now I've defined this rectangle. I'm going to hit escape to get out of dimension, double click to select the entire rectangle, and just kind of confirm visually that that's the size I want. That looks good for a tenon, but I want to use constraints to automatically place it in the middle there. So I've got my middle point here. I don't have a middle point here, but I'm going to use the exact same thing that Fusion used when I created a center rectangle. Fusion automatically drew 2 construction lines defining the center, and then it put a point in the center. So I'm going to manually do the same thing here. I'll go to my line tool, and I will go to construction line and click, making sure that I am getting coincided with those corners. That looks good. So now I can go to create and go down to point and position the point to snap right in the intersection of those 2 construction lines. So now we have the 2 points, and we can just align those 2 using a coincident constraint. So I'll click on that. I'll click on the one that I want to keep. Remember, click to keep. So I'll click there, and I'll come over here and click on the one that I want to move. And now our tenon sketch is automatically centered right in the middle of our piece. So all that's left to do now is to show the sketch here and pull, extrude out its profile. Now, even though I can see through this leg, it still is a solid. So I can't hover over this and get the profile I want. So 2 options. I could hide the leg over here, but much easier is to use my drill down technique. So I'm holding my left button down, I get this menu, I release the button, and then I just move through this menu until the profile that I want gets highlighted. And there it is right there. Okay, so now I can hit E for extrude, and I'm going to pull this back into the leg. This is going to be a join, and I'm going in a negative direction, and I want this to be half, I want the mortise basically, or the tenon, to be half the length, the width of the leg. And remember, the leg width and depth are the same. There's just a single parameter, leg width. So I'm going to do leg width divided by 2, press enter, and there is our tenon. So now we're in a position where we can replicate that on the other side of the board. on the other side of the piece. So we will use our mirror command to do that, and we're going to mirror a feature, and we're going to select that feature, which is the extrusion. You can see it gets kind of dark highlighted. And then we are going to need a mirror plane. So let's select. Conveniently, our origin planes pop up, and I'll click on the appropriate one. And now we've got the tenon on both sides of our piece. I'll click OK. And now if we go back to our top level timeline, it's just a matter of letting the timeline play out. And right here, we should have the piece mirrored to the other side. Let's right click on this leg and find in browser. So it opened it right up. And so that's our leg right front. I'm going to hide that just to make sure I have my tenon there. I'll actually look at the right rear and right back and confirm that that tenon was placed there too. So we got we sketched one tenon, extruded one tenon, got it mirrored on the other side, and then got the whole piece mirrored, all with a little bit of timeline manipulation. Next, I'm going to create the tenons on the aprons, on the top pieces that are perpendicular to these two stretchers. So the aprons don't even exist yet. First off, I'm going to unhide all the legs that got hidden, and I'm going to clean up my browser a little bit. So let's move along the timeline until we get some stretchers. Okay, so we want to move backwards to a mirror command and actually go a little bit before there. Okay, so we have one apron piece, which is good. So this is the point that we want to do our work in this apron to add our two tenons, and then allow that piece to get mirrored along with its tenons. Okay, so I'm in the right spot. I want to go to the only apron that exists at this point, activate that. Let's look at its sketches, and we don't have any sketches here. So we're actually going to create a sketch on the end of one of these aprons. So I'm going to go up to create sketch. I think I'm going to pre-select the end of this first because it looks like it's a little sketchy. Not to do a pun there, but it's a little sketchy to get into to find this. So I want to make sure I've got it before I start the sketch. So I'm going to use my drill down technique. I'm holding down my left button, and then I'm going to hover over the face, and I see that one highlighted, so I'm going to select that, and I get visual feedback. So all this happens before the sketch. So if I have misselected something, I don't have to undo to get out of the sketch. All right, so now I'm in my apron as the active component. I've got my sketch plane pre-selected, and I'm going to go up to sketch and create it. And so I'm looking straight at the end of my apron board, and now I want to sketch out the tenon. So this is pretty much identical to what we just did. Center rect. I'm going to go ahead and finalize it and then use my dimension tool. And remember, we don't have the dimensions of that. I guess that got sketched. I'm not really sure how that got sketched, but we don't have those dimensions here to do the little click thing that we did that we just did in the previous in the stretcher. So what we have are apron width and depth in our parameters. So I'm just going to start apron. So this is our apron depth right here, and I'm going to say divided by 2. And then I'm going to pull off another dimension, and this is going to be our apron width divided by 2. Okay, so now I'm going to double click and move this just to confirm that the tenon looks good, which it does. And now we want to do our 2 diagonals. So I will go to my line and get some construction geometry and snap in the corners. So this geometry is actually getting automatically projected into my sketch, which is very useful. So another diagonal line. Now there's an instance of where I pulled off too fast and I got this little short line. So I'm going to do a Control Z until that goes away. Pick my line tool again and be a little bit more deliberate here. Click, move away, and click. And I'll hit the check mark here to get out of line. And then I need to add that center point in at the intersection of the two construction lines. And then I can do a coincident. So I do my click to keep and click on this. This is going to move. So that moved to the center of the end profile of our apron. So we're done with our sketch. And this time Fusion leaves the sketch because it's a new sketch. If you create a new sketch, it'll leave it visible, figuring that you want to do an extrude or some other operation on that sketch. Okay, so we still have the drill down necessary here because we can't select through this solid leg. So I'm holding down my mouse button and I'm picking the profile from that little pop-up menu. And now I hit E for extrude. And now I'm going in a positive direction. I want a join and I want half the distance of the leg width. So leg width divided by 2. So our tenon is going to be halfway into that leg. And click OK. Now I don't want to make another sketch if I don't need to. So I'm just simply going to mirror this feature to the other side, just like we did for the stretcher. So I'm going to pick mirror, and I'm going to pick features, and I'm going to go to my timeline, pick the tenon extrude, select my mirror plane. Conveniently, the origin planes pop up, so I'm going to pick the appropriate one and click OK. And there is our second tenon. So now we wanted to go back to our top level component and do the mirror command in our timeline and just hide these two legs just to make sure everything's okay. So if I don't know what leg it is, I'm gonna right click and find in browser. There's the leg I want to hide, and I can see I've got the tenons. I think I'm just going to hide all 4 legs here just to show you that we've got all of the tenons in place and ready to go. So let's unhide the legs and go back to where we were in the timeline. So I've got my top level component selected. I'm going to hit this button to go all the way to the end of the timeline, which even puts the top on the table. Let me hide the top because we're still doing a little bit of work on the legs. So with all of our tenons defined in the apron pieces and in the arches, we can cut multiple mortises at once, basically cut every mortise in each leg at once using the combine feature. And since combine has a target that is essentially a component in this case, we don't have to worry about what the active component is. Fusion will figure that out for us. So we're going to go to our combine tool and we pick a target body. So this is going to be one of the legs. Okay. And we can pick multiple tool bodies. So in this case, multiple bodies to cut the leg with. So I'm going to select all 3 of these components that intersect with the leg. And instead of a join, I want to do a cut. And I want to keep tools, which means I do not want to delete these 3 components from the model. And I'll do an OK. And when Fusion is done calculating, I'm going to hide these 3. So I am shift clicking on all 3 and pressing V and then clicking away to unselect. And so now let's take a look. I've got my through mortise in the leg, and I've got my stopped mortise here and here. Very good. So I'm actually going to do a Control Z to undo that V command. V, I think, for visibility. So that'll toggle your visibility I think I probably could have done another V and showed those three, but we've got another chance to explore that. Okay, so that's the first leg. So now we just need to repeat that on the other three legs. Remember, we can do a right click. Oh, you know what? I can't because I just did a different command. Okay, so I'm going to come up and get my combine command again. There it is. Select my target body, which is the second leg. We're going to select the three intersecting members there. This dialog box is now already set from the previous usage to cut and keep tools. So we can confirm. Now we can go even faster. And now I can right click, do a repeat combine, click on the leg, click on the three tool bodies that intersect it. 1, 2, 3. Keep tools. Okay. And here's the fourth leg. Right click, repeat combine, choose the leg, choose the three cutters, keep my tools, and okay. So it's that quick to cut all of these mortises. So we cut what? We cut 3 times 4. So we cut 12 mortises in, oh, how long did that take? Not very long. So that's kind of a nice demonstration of the power of the combine tool. Since I went pretty quickly through that combine of using combine on the 4 legs, let's look at a way that we can verify that those mortises actually were cut without hiding stuff. So there are display settings here and visual styles, and one of them is wireframe with hidden edges, which is a Control-8 shortcut key. So if I do that, I can actually zoom in here and see that the mortises are cut, and I can also see the tenons too. So that's a nice quick verification that what we did was correct. So I'm going to do a Control-6, which is the shortcut to get into our solid model with lines. I don't remember exactly what it's called here. Let's see, visual style, shaded with visible edges only. Okay, so next up we're going to work on the top, and the way I defined the top initially wasn't quite right for making the breadboard ends. Let's go to the finished model and get out of that sketch, go up to the top level here and activate that, deselect, and you can see I guess this is before I made the breadboard tops. Okay, so we're not at the end of our timeline here, so I'm going to click our end of timeline, and you can see here are the 2 breadboard tops. They actually protrude out a little bit beyond the table, and they've got that same chamfering detail on them. So we're going to create a top that's a little bit smaller than before, and then 2 breadboard ends. So back to our working model. Let's enable the top, and I think what we're going to do is modify the top parameter, at least one of those 2 parameters for the overhang. So let's go into our parameters, and let's go down to our breadboard parameters. No, I'm sorry, our top parameters. Let's see, where are they? Top. Oh, here we go. Here's our 2 top overhang parameters. Top length and width overhangs. So I'm going to set the width overhang to 1.25 inches. Okay, 1.25, enter, and then I'm going to go to the top length overhang, and I'm going to set that to 1/2 inch. Okay, and get out of our parameters. And you'll see, because it's parameterized, we've got a much smaller top there. So now we can add our breadboard ends to that. Okay, so we have a couple new parameters to put in for our breadboard. So back to our parameters and create a new one, and this is going to be called breadboard width. So this is the width of the breadboard pieces, as if they were ripped on a table saw. Breadboard. Having trouble with my spelling here. Oh, there's B. Okay, breadboard width. And that's going to be 3 inches. And then I'll create another new parameter, breadboard. This is our breadboard length overhang. So this is how much the breadboard is going to overhang, basically overhang the table, the table depth, the table width. So I'm going to initially set that to 3/4 of an inch. Okay, this will make a lot more sense when we see it in the model. Okay, so now I'm going to activate my top, and actually I think I'm going to do nested components here. I want the breadboards to be part of the top so that when I hide the top, this inner top goes away and also the 2 breadboard pieces go away. Okay, so I've got my top activated. So now when I create a component, it's going to be nested inside there. So I'm going to click on my new component and I will call this breadboard. And then of course we're going to mirror that to the other side like we've done 100 times before. Okay, so there's breadboard. And now we can see that it's nested inside top, which is exactly what we want. So now we want to activate the breadboard component, but it got activated automatically, so we don't need to do that. And we're going to create a new sketch on the top, on the edge of the top, on the front edge of the top, and then make our sketch inside there. So a couple different ways we can do that. I kind of like the pre-selection here, pre-selection method. So I'm 100% sure that I'm getting the right plane before we get into the sketch. So there is our top. Our breadboard is going to be the same thickness as the top. So let's go ahead and make a rectangle away from the top. And let's see, if I tab to the other dimension, this is going to be our top depth. So I'll pick that out of the list, so the thickness of it. Now this is going to be our, let's see what we have here. We have our base. This gets a little complicated, but we have our base depth, the depth of that base rectangle that we drew. So that'll take us out from outside leg to outside leg. And then what do we want? We want our plus our breadboard length overhang. And let's see where that gets us. But actually we want that overhang in each direction. So that's going to be multiplied by 2. And then I think we also want to add in, a little too complicated here, but the tabletop had an overhang as well. So I'm just going to type in OH, and let's see, our top width overhang, and we're going to multiply that by 2. So I apologize for the overly complex formula there, but you could define, an actual top parameter. But basically, we were trying to keep everything based on this base, this wireframe that we made initially. So from the wireframe, there was a top overhang, but we want 2 times that. And then the breadboard has an additional overhang beyond the top. So let's look at that formula again. So I'll actually move the dimension up here. Double click on it, and there's the whole formula. So it's base depth, which is from here to here, plus the breadboard length overhang, which is the distance the breadboard overhangs the top, 2 times that, and 2 times the top width overhang, which is this dimension here. So I think that's what we want. So I'm going to press enter here. All right, so let's just position this rectangle manually and kind of see that's what we want. So that breadboard, I think it overhangs by 3/4 of an inch on each side. We want this to align to the top. So we can use a coincidence to do that. Actually, we're going to use a collinear setting here. So we're going to say the top piece of the rectangle is going to be collinear with here. Let me correct that. I'm not going to do that because that would bring us down here, but then we'd also have to center it. I think a better choice would be to do a midpoint. So we can make the midpoint of this line line up with the midpoint of this line. So we will click here and see if we can get a midpoint. I don't see one, so I'm going to hold down my shift key. I'm still not getting one. So in this case, I'm going to go up to my line, and for some reason the line tool will get one. So I am in the center of the top. I'm just going to draw a little vertical line and get out of my line tool. I forgot to make it a construction geometry, so I hit escape. I click on the line, press X, it's now construction, and I've got a little endpoint on that line, so I think that's all we're going to need. And now if I do a midpoint, I can click there, I believe, and click here and get those two to align. So let's give that a try. So midpoint, click here, which is the midpoint of that line, and click here. And it said it failed. Okay, so let's try a different approach. We can also get a midpoint here in this rectangle by going to our line. I'll turn on construction line geometry this time. Here's our center. I just went from center to center. Now, can we do a coincidence between this point and this point? And that worked. Okay, so a little bit of fumbling around, but we got through the constraints. Okay, so now we have this breadboard, and you can see its profile extends out beyond the table. It's not going to look quite so clunky once we do the chamfers on the end there. Okay, so now we're aligned so we can finish the sketch. We're in the right spot. We're actually, the sketch plane is at the end of the inner part of the table before the breadboard. And I'm going to hit E for extrude. And now this is going to be our breadboard width. So let's see, was that negative or positive? That is positive. So breadboard width, and press enter. And we've got one breadboard made. Now we want to do the chamfers on each end before we mirror the breadboard to the other side. And then we have to do the mortise and tenoning to attach the breadboard and the inner top together. So we'll go into the chamfer tool, and let's see, we will select a face. Make sure we got the right face here. Okay. Now, we're in distance and angle, so the distance is going to be our top depth, the thickness of our top divided by 2. And our angle is going to be 30. And there is our chamfer. Let's take a look at it. So chamfered on all 4 sides because we picked the face instead of individual edges. So I think we can swing around to this other side and do the other chamfer by hitting plus here and also clicking on a face. So hovering over this, making sure that the proper face is highlighted. And we want our same depth, so I'm going to try to cut and paste that. So I'm going to do a Control C and go to the second chamfer in our list and do a Control V and set that one also to 30 degrees. That looks good. And then an OK, and our chamfer is complete. So it's tempting at this point to mirror our breadboard over to the other side and kind of see what's going on. But there is a long tenon in the edge of the tabletop and a long receiving mortise in this breadboard. So I want to do that joinery before we mirror the breadboard so that we don't have to do any timeline manipulation. So first thing I'm going to do is I'm going to hide the breadboard component. I didn't hide it, I activated it, sorry. I'm going to activate my top again and deselect everything. So now I'm in a position where I can make a sketch on the edge of this inner tabletop and define the tenon. And then we'll use the tenon to cut the mortise in the breadboard. Okay, so top is activated. Pre-select the edge of the table, go up to sketch. We've got our sketch plane defined. And now I'm just going to make a rectangle away from everything. And you know what? I think I'm going to undo that and I'm going to do a center rectangle in case we need that for centering, which we probably do. So I'm just going to accept whatever the dimensions are there and then end up dimensioning it myself. So D for dimension, pull off, click. So this is going to be half of the thickness of the table thickness. So top depth divided by 2. And then I want the width of this mortise, I think I want the, I'm sorry, tenon. I want it, you know, from this outer leg to this outer leg. That'll give us plenty of holding power. So I'm going to hit D, come up off of this edge, and so that's our base depth. So the full base depth, I'll hit enter. Our sketch gets quite a lot bigger. Now let's take a look. So double click, move that into place. All looks well. Okay. So now we want to align centers. This center to this center. If we hover over here, do we get anything? Nope. Okay, so a couple different ways to do this. I think a single centering plumb line might be the best, and especially if we make it the height of the table, then we can do midpoint from there to there. So again, a little demonstration is probably better than me babbling on, but I am looking for the center of the tabletop. So I click there, and now I'm going to click on the bottom. I want this line to be the full height of the table because we're going to use this midpoint to align with that midpoint. So I want construction geometry, so I hit escape and then go to my select tool and hit X. Now I've got construction geometry. So now I think I can use the midpoint of the line that we just created and this point. So let's try it. So midpoint, click to keep, and this point right here. Did I click on the point? All right, let's try that again. Midpoint here, this point, and there it is. Okay, I guess I didn't click. All right, so the tenon is in place, properly dimensioned, so we'll finish our sketch. And now it's just a matter of extruding this. And I think what I'm going to do is I'm going to extrude it based on the width of the breadboard. So I'm going to do E for extrude, and then we'll come in and say half of our breadboard width. So breadboard width divided by 2. And there's our tenon. Okay, so we want that on the other side of our table also. We're in our top, so I think we're safe to just mirror this right now. So we go to our mirror command. We're already in features. We will select the extrusion that we just did out of the timeline and then select a mirror plane using the appropriate plane out of our origin and preview. It all looks well, so click OK. Wait a second for Fusion to calculate, and there is our tabletop tenon. So now when we unhide our breadboard, we can activate our top again and make our breadboard visible. Our breadboard's in the right spot, but let's go ahead and cut the mortise in our breadboard and then mirror it to the other side, and I believe we'll be all done. So we are going to do a combine feature to do that. So I'm going to click on combine, And my target body is this breadboard. My tool body is the tabletop. It's going to be a cut operation. Keep the tools. Boom. Okay. So let me click on this and do a V to hide it. And you can see there is our mortise. So I'll do another V to unhide it, and that does not work. So I'm going to have to go into our bodies, I believe, here, and turn our tabletop body back on. Okay. So now we should be able to mirror this component, and I think that's the last thing we have to do in this model. So we go to mirror. We don't want to mirror features. This time we want to mirror components. We want to pick our component, which if we expand our browser, that's this breadboard right here. And we're going to select a mirror plane, which is a plane in our origin. And now we should see another breadboard in our browser. There it is right there. So if we're looking at, let's see, here's the front of our table. So let's just do a little cleanup here. We can call this breadboard-L. And click a second time after waiting a second. And breadboard-R. So there are our two breadboards, which we can independently hide and show. But the nice thing is making these inside our top component, we can hide all three of the top pieces at once. So let's activate our top level component and take a look. Everything looks good. I think at this point the only thing I'd like to do is I want to go to cherry, which seems to be the species used most often in arts and crafts style. So I'll press A for appearance, and we're going to search for cherry. And here's a 3D cherry glossy. That looks good. So if you see a down pointing arrow here, that means you've got to download the appearance to your system before you can use it. So I'm going to click on that down pointing arrow, and now I can drag my cherry 3D all the way to the top level component. Now it's saying, do you want to change the appearances of your child components? I believe the only child component that we changed was air for our base wireframe. Let's see what happens if we do a keep here. Yeah, that worked fine. So we kept the base wireframe in its air, basically its transparent mode. And now we have a cherry table. And let's take a look. We've got all our arts and crafts details, which are the, through tenons, and our chamfers on all four sides, and our little grid blockwork in the middle, and breadboards on the top, and this little detail of the breadboard overhanging on the end. And with our fully parametric design, if we don't like the dimensions of this table, we can just go into the parameters and change it. So that's our table.